We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Could it be possible that something out there is not just drifting through space, but deliberately heading our way? An object so massive and unusual that scientists themselves admit they can't explain it.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
31/ATLAS. New image sparks fear among scientists. Is this just another come or something far more unsettling? Let's explore. A strange visitor in space. Not long ago, the James Webb Space Telescope pointed its powerful eyes towards something very unusual moving through our solar system. This mysterious traveler is called 3I-ATLAS, an interstellar object that came from outside our solar system. For a long time, scientists waited for the telescope's first observations, and at last, the results have been released. Around the same time, another telescope known as SPHEREX also shared its findings about this same object. Both of these observatories are designed to study space using infrared light. Normally, they focus on very distant things like galaxies or giant clouds of gas and dust. But this time, because 3I Atlas is so unusual and puzzling, scientists decided it deserved special attention. Even with the combined power of these telescopes, the mystery deepened. Neither was able to clearly explain what 3I-ATLAS actually is, how large it might be, or exactly what materials make up its body. The more they looked, the more questions appeared. 31/ATLAS. New image sparks fear among scientists. What the James Webb Telescope did reveal, however, is that this object is not like any comet or asteroid that humans have ever studied in detail. Its features stand apart from anything previously seen moving through our solar system. This makes it not just another passing rock, but a true cosmic puzzle. To add to the mystery, another research paper came out recently, this time focusing on the possible technological aspects of interstellar objects. The study included information about Oumuamua, the first interstellar object discovered years earlier. The findings confirmed what many scientists already suspected. Oumuamua was also extremely unusual and did not behave like any known natural object. So, the story begins with two strange visitors from beyond our solar system. Each one behaves in ways that make scientists question what they truly are. Nama's long silence. It seemed unusual that NASA waited so long to share any kind of analysis about 3I-ATLAS. At first, many wondered why, but one possible reason is that the object is so unusual that it may have taken time for scientists to even come up with a possible natural explanation. And even then, the explanations do not seem to fully match what is being seen. The truth is, NASA has not been able to provide a clear natural answer for what this object is. Even though some early results show that 3I-ATLAS has a few features similar to a comet, the details reveal a very different story. The elements that scientists expect to find in a typical comet's glowing cloud, called a coma, do not fully appear here. Step by step, it is becoming more obvious that this object does not behave like anything else ever observed moving through the solar system. Even NASA is slowly starting to admit this. To make things even more interesting, Avi Loeb, a well-known scientist who often writes about space mysteries, quickly published his thoughts on the new James Webb data. Only a few hours after the telescope results became public, he shared an article on Medium explaining what the findings mean. He described how, while boarding a flight to Copenhagen, he received the official report about the telescope's observations from early August of 2025. Waiting for the plane's Wi-Fi to load felt like forever, but once he read the paper, he said the data was worth the wait. According to Loeb's breakdown, the James Webb Telescope detected a massive cloud of carbon dioxide gas surrounding 3 IATLAS. What made this so unusual is that only very small amounts of water and carbon monoxide were present. Normally, comets release large amounts of water as they approach the sun, but this one does not. The small traces of water that were finally detected appeared at surprisingly low levels. Meanwhile, the SPHEREX Observatory had also studied the same object and found similar signs. However, SPHEREX showed that the carbon dioxide cloud stretched incredibly far more than 348,000 kilometers out from the object. To put that into perspective, this makes the halo of gas about half the width of the sun itself. So, instead of solving the mystery, these results made the puzzle even bigger. As the old saying goes, the more we know, the less we understand. A bright object without a tail. One of the strangest things about 3IATLAS is that it does not have a comet-like tail. Normally, when comets travel close to the sun, they release large amounts of gas and dust. The solar wind then pushes this material backward, creating the long, glowing tail that most people recognize. The Hubble Space Telescope took a high-resolution image of 3IATLAS, and it clearly showed that no such tail exists. This missing tail reveals something very important. It suggests that 3I Atlas is not shedding many dust particles, especially the small ones that are about half a micrometer in size, which normally scatter sunlight. Instead, the brightness we see most likely comes directly from the surface of the object itself, not from a glowing halo of dust around it. Even though it shines brightly, the light appears to bounce straight off its surface. Based on this, scientists estimate that 3IATLAS could be as wide as 46 kilometers. The James Webb Telescope's data support this size, assuming the object reflects only about 5% of the sunlight that hits it. This reflectivity is called albedo. But here comes another twist. If the surface of 3I Atlas were more reflective, maybe metallic, like shiny rock, or even mirror-like, then the object would not need to be that large to appear so bright. In that case, its true size could be much smaller. Scientists are still testing these ideas to understand what makes it shine so strongly. To dig deeper, researchers used infrared spectroscopy, which breaks down the light coming from an object to study its ingredients. At a distance of just over 3 astronomical units from the sun, the James Webb Telescope captured detailed spectral images. These images showed that carbon dioxide dominates the gas cloud around 3IATLAS. The object also releases small amounts of water vapor, carbon monoxide, ice, and dust. What stood out the most was the unusual ratio of gases. The amount of carbon dioxide compared to water molecules is about 8-to-1. This is the highest ratio ever measured in any comet. Normally, comets have far more water vapor. But here, the water is surprisingly scarce, given how close the object is to the sun. The spectrum also revealed a strong carbon dioxide signal, weak traces of water and carbon monoxide, and a clear sign of water ice. But here is the puzzle. Even though the ice is present, it is not turning into vapor as expected. This strange mix shows that 3IATLAS is very different from the comets that astronomers have studied before. The strange case of hidden ice. One of the most puzzling things about 3IATLAS is the way its ice behaves. Scientists have detected water ice on the object, but the ice is not turning into vapor the way it should when warmed by sunlight. This process, called sublimation, is what usually makes comets release large amounts of gas. In this case, however, the ice seems locked in place, refusing to escape into space. Measurements show that 3I Atlas is losing about 130 kilograms of carbon dioxide every second, while the amount of water vapor escaping is only about 7 kilograms per second, and carbon monoxide about 14 kilograms per second. That means the water output is just 5% of the carbon dioxide output. To put this in perspective, this is about 16 times more unusual than what scientists would expect from a normal comet at the same distance from the Sun. These numbers are taken directly from the official study, not just from interpretations. Using this data, scientists also estimated the size of the nucleus, or the solid center of the object. Observations at 1 micrometer wavelength from the Sphere-X telescope suggest that 3I Atlas has a diameter of about 46 kilometers. If that estimate is correct, then its mass would be 1,000,000 times greater than the interstellar comet 2 I Borisov and several million times heavier than Oumuamua. This massive size raises a new problem. If giant interstellar objects this large exist, then smaller ones like Borisov should be even more common, and should have been detected many times already. Yet that has not happened. To make things even more confusing, earlier studies predicted that the amount of rocky material drifting through interstellar space is far too low, 10,000 times lower, in fact, to make the discovery of a single object this size within just a decade of searching possible. The James Webb telescope also captured an image at a wavelength of 1.2 micrometers. Once again, it showed no cometary tail stretching behind 3I Atlas. Instead, the glow seen around it might come from sunlight reflecting off fragments of frozen carbon dioxide, not dust. These icy bits could slowly evaporate in the sunlight, creating the wide carbon dioxide cloud around the object. Yet, this explanation still does not solve the mystery of its brightness. The shining light we see must mostly come from the nucleus itself. According to the calculations, the carbon dioxide loss is equal to a millimeter-thick layer of the surface being stripped away over just a few years. That means only a thin outer skin is needed to keep up the massive gas cloud around 3IATLAS. Ratios that do not add up. The high amount of carbon dioxide compared to water in 3I Atlas is one of its strangest features. Only one other comet has ever shown a ratio this extreme, Comet C, 2016 R2. But even that comet looked completely different. Comet C, 2016 R2 had the classic comet tail streaming behind it, something that is totally missing in 3IATLAS. Instead, this object has a strange glowing plume with no clear tail at all. The James Webb research team has suggested a few possible reasons for this odd mix of gases. One idea is that the surface of 3IATLAS reflects so much sunlight, or blocks heat so effectively, that water ice deep inside does not easily turn into vapor. Scientists call this reflectivity albedo. If the albedo is low, like 5%, the object would be about 46 kilometers wide. But if the surface were as reflective as a perfect mirror, with an albedo of 100%, then its estimated size would shrink to about 10 kilometers. The problem is that a natural object with a perfect mirror-like surface seems almost impossible. And even with this smaller size, the discovery still raises big questions. According to earlier studies, there simply should not be enough rocky material drifting between the stars to explain how such a massive object ended up in our solar system so soon after surveys began. One possible way to make sense of this is to suggest that 3IATLAS is not just a random piece of rock floating in space. Instead, its path may have been guided intentionally or otherwise to pass through the inner solar system. Its trajectory already looks unusual. It closely follows the plane where most planets orbit. It comes within the distance of one astronomical unit of 3 different planets. And when it makes its closest approach to Earth, it just happens to be on the far side of the Sun, perfectly hidden from our view. To give a sense of scale, Avi Loeb pointed out an eye-opening detail. On average, a single human exhales about 1 kilogram of carbon dioxide each day. 3I Atlas, on the other hand, is releasing 130 kilograms every second. That equals the carbon dioxide output of around 10 million people. Now imagine a platform in space with a diameter of 46 kilometers. Packed as densely as people living on Manhattan Island, it could hold 10 million humans or perhaps even some other kind of living beings. That comparison makes the mystery of 3IATLAS even more unsettling. Looking back at Oumuamua. Earlier, the strange visitor called Oumuamua became the very first interstellar object ever seen passing through our solar system. Its discovery opened the door to questions that are now being asked again about 3IATLAS. When comparing the two, the differences stand out. If 3I Atlas shows only faint hints of carbon monoxide and water, but huge amounts of carbon dioxide, then maybe this is not really a comet at all. It could instead be a massive asteroid, possibly more than 40 kilometers wide, and the thought that it could even be a type of spacecraft is not impossible. The idea of using an asteroid as a ship is not science fiction alone. Scientists have suggested that an advanced civilization might use natural space rocks as protective shells for long journeys. Even humans could one day use the same method for interstellar travel. A thick body of rock would shield travelers from dangerous cosmic rays during trips that could last decades, centuries, or even thousands of years. Ice could also help, since water is one of the best shields against radiation. That is the same reason water is used inside nuclear reactors for protection. But the conversation does not stop there. New findings about Oumuamua were also revealed recently. Many scientists in the past strongly disagreed with Avi Loeb's suggestion that it might have been an alien artifact. Yet now, even some of those critics are starting to agree that interstellar objects should be taken very seriously. They argue that searching for technosignatures, possible signs of technology, might be wise. Some even suggest that if we cannot figure out exactly what these objects are, sending a signal toward them could be a smart move. And the latest data only makes Oumuamua even more mysterious. For years, it was difficult to measure exactly how unusual it was, but now, numbers confirm what many suspected. Its movement did not match the behavior of any other natural object ever observed. Its non-gravitational acceleration, the way it sped up or slowed down in space, was unlike anything else known. A new research paper titled Technosignature Searches of Interstellar Objects makes the claim that the first interstellar visitor, Oumuamua, was not a technological object. The authors state that most scientists agree there is no solid evidence to suggest that it was built by an advanced civilization. They argue that its unusual acceleration could be explained by natural causes such as outgassing or the gentle push of radiation pressure. But here is where things start to get puzzling. The actual data presented in the study does not fully support those claims. In fact, the behavior of Oumuamua seems to break the rules of what natural objects are expected to do. First, let us look at its speed and path. Before it entered our solar system, Oumuamua was moving in a way that matched something called the local standard of rest. In simple terms, it was almost standing still when compared to the average motion of the stars around it. This is incredibly rare. If it were designed as some sort of navigational marker, this kind of motion would make perfect sense. Next, by what seems like an extraordinary coincidence, Oumuamua used the sun's gravity to perform a slingshot maneuver that brought it very close to Earth. It passed right through the Goldilocks zone, the region where liquid water could exist, and came within about 1/5 of the distance between Earth and the Sun. The odds of such a perfect pass happening by chance are tens of thousands to 1. The shape of the object was also unusual. Observations suggest that it was either a very thin disk or a long, stretched-out, stick-like shape. That form does not match the bulkier and more irregular shapes normally seen in asteroids or comets. Finally, and most importantly, there was its strange acceleration. As Oumuamua moved away from the solar system, it suddenly sped up. This could not be explained by the push of sunlight alone, nor by gravity from the sun. No known natural process fits the way it behaved. All of these details make Oumuamua unlike anything else ever observed, and they leave scientists with more questions than answers. A mystery that will not go away. Dark comets are thought by some astronomers to be real, but they remain highly debated. Avi Loeb has pointed out that some of the so-called dark comets might not be natural at all. In fact, he demonstrated that several of these sightings were actually spacecraft launched by humans. According to this view, it is even possible that every dark comet identified so far has turned out to be artificial. The behavior of Oumuamua stands out. Its acceleration was greater than that of all the asteroids and comets, except for a few comets that exhibited enormous visible outgassing. In those cases, the gas jets blasting off the surface of the comet made the extra push easy to explain. But in the case of Oumuamua, no visible outgassing was seen at all. Some scientists have suggested that invisible outgassing might be occurring. Yet, even if that were the case, the effect should have been much weaker. The acceleration of so-called dark comets is about 100 times less than what was observed with Oumuamua. For the invisible gas idea to work, the object would have to be made almost entirely of very fragile materials, like nitrogen or hydrogen ice. These types of ice boil away at extremely low temperatures, so it is very hard to imagine them surviving a close encounter with the sun. And even if such a strange object did somehow exist, scientists would still expect to see some kind of debris spilling away as the gases escaped. The amount of acceleration recorded requires a huge release of material. Yet no such debris was ever seen. Avi Loeb chose not to argue directly with his critics in the paper, instead sticking to the consensus view. Still, the data presented makes something very clear. Oumuamua does not behave like any known comet or asteroid. It remains completely unique, and the possibility that it is artificial cannot be ruled out. When all of this is placed side by side, the picture becomes even more fascinating. Out of the 3 interstellar objects studied so far, one was a fairly normal comet, 2I Borisov. But the other 2, 3I Atlas and Oumuamua, both show features that suggest they might have been built, not born. If 3I Atlas and Oumuamua are both this strange, how many more mysterious visitors could be passing through our solar system completely unnoticed? If that thought gives you chills, make sure to hit the like button, share this video, and subscribe so you don't miss the next. And let me know in the comments, do you think these interstellar objects are natural? Or is it possible they were sent here on purpose?